So, thank you Mick for giving me the chance to give you an update on our MAP pressure sensor portfolio. You know, MAP sensors are used in the combustion engine to control the engine, to make it more efficient and to reduce the exhausts, and to fulfill the exhaust regulations. So this opportunity is great because we just have released our latest version of digital manifold absolute pressure sensor. This sensor KP276 is based on our well-known portfolio of automotive pressure sensor. This is the technology we use for our well-known analog sensors and also for the digital for MAP and BAP applications. It's a technology we use since a lot of years and where we have really an exceptional track record. Now this new KP276, you know, we have released in 2016 the first digital MAP sensor KP275, and this is already now the second generation. What's new now? It has an accuracy of 0.77% over the full range, and this is great because this is what the customer really needs. Additionally, we have now reduced the startup time. This means within 10 milliseconds you have the pressure value and also the temperature value with the needed accuracy. And finally, we have also improved the SEN protocol. It's now fulfilling the latest standards, so it's a standard version 4, and within 282 ticks you have the full frame. Now what is also important, it has the same media robustness as our KP275. It's hard to see, we have removed the lid, but this has a gold plating on the lids and also on the pads. So it can be used for EGR applications and also for applications where you have iodine in the exhausts. Now with this KP276 we have now really the perfect portfolio for customers who have any kind of MAP applications. Either it's really a classical MAP one, or you will use it for ORVR, also for EGR, or for diesel particle filters or gasoline particle filters. The pressure range is from 1 to 4 bar, so it means you can use it for turbo maps as well as for normal maps as you have in two-wheelers.
So my name is Axel. I just want to introduce you to a new current sensor what we have. A magnetic-based current sensor which can be used to detect and measure currents up to 100 amps and beyond. The specific thing what we have is, if you look into the market, there's quite a high number of magnetic-based current sensors. Most of them are core-based, like you can see here on the right-hand side. The principle is you have like a conductor which is carrying a current, and then the core is picking up as a magnetic field and leading the magnetic field to a field concentrator. So this is a standard principle which is widely used. The disadvantage of this principle is that typically the current sensor has half of the size of the box. So Infineon is using a slightly different principle. With this slightly different principle, so we have also a conductor. Magnetic current is generating a field, and we are picking up the magnetic field by 2 hole probes. This leads to a solution which is from a form factor much smaller. Here you can see actually 3 of those devices. The form factor is 8 by 8 millimeter and have a thickness about 1 millimeter. With that one, you can actually measure currents up to 120 amps. You have isolation voltages of 690 volt and above. You are also able to achieve a very low error, below 2% at 25 degrees, and error below 3% over the lifetime of the product. And typically you have an analog bandwidth of 120 kHz. So in addition, what we have also implemented are overcurrent detection outputs, which you actually can program and can use to detect overcurrent. This comes in a very small package, as shown before, with a very low resistor of 225 microohms, so that you can really measure this nice high currents.